Hello everyone. Previous classes we have learnt about what is moment of inertia and what is inertia tensor and relation between inertia tensor and angular momentum, and we have also seen what is symmetric nature of inertia tensor. So based on those topics, so now today's class will be dealing about the precision of spinning top. So to know the precision of spinning top, we should know what is the difference between spinning and precision. So if we know the difference, then only we can understand the precision of spinning top. Myself S. Vidyarani, working as Assistant Professor of Physics at MBS Government Degree College Autonomous Mehboob. So first let us know what is about precision and what is spinning, and we will come to know about precision of spinning top. I think there is a eye-catching animation here. Here a top is rotating. Normally in our childhood we would have played with a top, so we would have spinned a top, but we don't know the physics behind that. Why that body or why that top is not falling to the ground when it is spinning, and does it contains spinning or any other mechanism so that it is not falling when it is moving. Once its velocity reduces, what happens? It falls off to the ground. That means until it is moving, then it will not fall onto the ground. It will not experience the gravity. But once it stops, what happens? Once it stops rotating, what happens? This body feels the gravity, and then this body falls off to the ground. So we will see what is the secret behind the spinning top. First we will see precision of spinning top. So to understand this concept, first let us see what is precision. Okay, precision can be defined as the rotation of the axis of rotation of the spinning top is called as precision. So that means the rotation of the axis of rotation of the spinning top is called as precision. So if I say like this, you don't understand anything. I'll show you visually in later slides so that you will understand the difference between spinning and precision. So, or else we can also define that the axis about which the direction of rotation of the body precedes is called as the axis of precision. So a symmetrical body rotating about an axis which is fixed at one point is called top. So if you see the figure here, so this is a symmetrical body rotating about an axis which is fixed at one point is called as top. So a rapidly spinning top will precede in a direction determined by the torque exerted by its weight. So when a top is spinning, so it will precede in a direction determined by its torque exerted by its weight. So the precession angular velocity is inversely proportional to the spin angular velocity, so that the precession is faster and more pronounced as the top slows down. You might have observed when the top spin is slowed down, that means its velocity is slowed down, then the precession is more faster. So when the top is having less velocity, then its precession angular velocity will be more when compared to spin angular velocity. That means they both are inversely proportional. If spin angular velocity is less, then precessional angular velocity will be more. So the direction of the precession torque can be visualized with the help of the right hand rule. So to visualize the direction of precession torque, so we can take the help of right hand rule. So if you observe the figure here, let us say a top is rotating on a ground. So direction of spin is in this direction. Weight of the top is downwards, mg, straight downwards vertically. And this is the angular momentum L. So we know that L is equal to I into omega. So spin angular momentum, this is see here. And direction of precession, this is direction of spin. When we might have observed that when a top rotates around its own axis, as well as it makes a rotation around its head, if you might have observed, in a circular way. So the top rotating about its own axis is called as rotation. But if a top rotates on the whole with the axis of rotation, then we call it as precession. That means if a top rotates around its own axis, then it is called as rotation. But if the total body or total axis of rotation and the top makes an circular movement around a straight line, if you observe, so this is called as precession. So gravitational torque, if you this mgl produces precession. What causes precession is that the weight of the body, that is mg. Let's suppose the weight of the mass of the body is m and gravity acceleration due to gravity is g. So m into g gives the weight of the top. So weight of the top and product of weight of the top and angular momentum, that is L. So this is nothing but torque. So this helps the top not only to spin or not only to rotate, but it will also precess around a axis. So spin a top on a flat surface and you will see its top end slowly revolve about the vertical direction, a process called precession. So if you spin a top, you might have observed that spinning top starts rotating around its own axis, but in addition to that, it also the top also revolves around a vertical direction, which is called as precession. So as the spin of the top slows, that means when the top starts rotating slowly, you will see that this precession gets faster and faster. So when the top speed or top spin becomes less, then the precession will be more, that means faster and faster. It then begins to bob up and down as it precesses and finally falls over. Then what happens after some time, slowly its spin starts decreasing. So it then begins to bob up and down as it precesses and finally it will fall over to the ground. Showing that the precession speed gets faster as the spin speed gets slower is a classic problem in mechanics. So the process can be summarized in the illustration below. So if you observe here, so this is the mechanism of the precession. So direction of spin is this, top is rotating, so this is called rotation. So the precessional angular velocity of a spinning top is inversely proportional to its spin speed. Omega p is nothing but precessional velocity, precessional angular velocity. Omega p is equal to delta t by delta t. Delta theta is equal to precession angular velocity by this omega p can be written as delta L by delta t into L sin phi. So or else this can be written as tau by, when we using equations, when we simplify, we get tau by L sin phi. We know that delta L by delta t is nothing but tau. So tau by L sin phi, which is equal to, tau can be written as mgr sin phi. So here we have got the distance r. So mg is the weight here. So mgr sin phi by L sin phi. So sin phi gets cancelled. So we get precessional angular velocity omega p as mg r by L. So L is nothing but product of moment of inertia and omega, hence mg r by I omega. If you see lever arm, so this we will get it as r sin phi. And torque is equal to tau is equal to mgr sin phi, that is equal to delta L by delta t. If you observe, the center of mass of the top is here. So hence weight is acting vertically downwards here. So this L, that is angular momentum L, is equal to I omega, is in this direction. And if you observe here, the angle made by this arc is delta theta. After time, delta t, and delta L is the angular angular momentum, change in angular momentum from this point to this point. So delta t is nearly equal to delta L by L sine phi. So this is how we will define the precision of a symmetric top. So this process involves a considerable number of physical and mathematical concepts. So the angular momentum of the spinning top is given by its moment of inertia times its spin speed, but this exercise requires an understanding of its vector nature. A torque is exerted about an axis through the top's supporting point by the weight of the top acting on its center of mass with a lever arm with respect to that support point. Since torque is equal to the rate of change of angular momentum, this gives a way to relate the torque to the precession process. From the definition of the angle of precession, the rate of change of the precession angle theta can be expressed in terms of the rate of change of angular momentum, that is delta L, and hence in terms of the torque. So the expression for precession angular velocity is valid only under the conditions where the spin angular velocity omega is much greater than precession angular velocity omega p. That means when the top slows down, the top begins to wobble. Wobble means it will start balancing itself so that it do not fall. When the top slows down, the top begins to wobble, an indication that more complicated types of motion are coming into play. So you might have observed this. See here. So this is a figure to show the spinning and precision. See here, L is the angular momentum, omega is the angular velocity. So they both are perpendicular. This is how you can show visually. So now comes gyroscopic effect. A gyroscopic effect is nothing but, first let us know what is gyroscope. So gyroscope is nothing but if the fixed point about which a symmetrical body is spinning about its axis coincides with the center of gravity of the body is called as gyroscope. So if the fixed point about which a symmetrical body is spinning about its axis coincides with the center of gravity of the body is called as gyroscope. So gyroscope is a device which is characterized for its greater stability of axis of rotation. So the spinning rotor has an axis of spin. A couple acting about this axis can only ever change the spinning speed. So to change the direction of the axis of spin, the only remaining possibility is to apply a couple at right angles to the spinning axis. So the axis of spin will deviate so as to direct the direction of the applied couple. This is called as gyroscopic precision. So more precisely, the angular momentum changes in the direction of the applied couple. Angular momentum is a measure of how fast the rotor is spinning. So with reference to the diagram, the spin axis angular momentum is the black arrow and it responds to the applied couple green arrow by changing in the direction to give a new spin axis, and this change in direction is called as precision. These arrows are called vectors. So we will see the figure also. So to figure out the arrow relates to the direction of spin, just point along the arrow and then wiggle your finger clockwise. There is an important result from all of this. You get slower precision if the spin is fast or if the couple is small. This is because the smaller the couple or the larger the spin angular momentum, then the change in spin direction is smaller. So spinning symmetric tops are prolonged or oblated bodies with a cylindrical or discrete rotational symmetry whirling around their symmetry axis En, having one point fixed or at least restricted to move on a surface. So the symmetry axis coincide with the principal axis having the smallest or highest moment of inertia, while the two further principal moments of inertia associated with the perpendicular principal axis have the same magnitude. One of the characteristic phenomena exhibited by spinning tops is precession. This term is used to refer to several phenomena having different physical origins. Conversely, in different fields of science and engineering, the very same event may be called as precession or wobbling or nutation. Now we will see what is torque-free precession. So this occurs when no external couple of forces is acting on the top. That means its symmetry axis will sweep around the mantle of a cone with opening angle theta, hereinafter nutation angle, while the total angular momentum L of the system, which determines the axis of the cone, is conserved. The mainstream physics literature refers to the rotation around the precessing symmetry axis as spinning, while to the rotation around the steady axis defined by the angular momentum as precession. Just now I have told that rotation around the precessing symmetry axis is called as spinning. Rotation around the steady axis is defined by the angular momentum is called as precession. Note that different points of a freely precessing body are subject to acceleration which varies in space and time. Therefore, mechanical tensions will arise within precessing free tops. This phenomenon has a major importance in planetary physics. So, with this example spinning top, we can also explain the equation of equinoxes or rotation of equinoxes of the earth. So, torque induced precession takes place if a spinning top is exposed to a couple of forces, also referred to as movement or torque. Tops with an axis having a cylindrical or at least a third order discrete rotational symmetry spinning around this axis and exposed to a torque follow a regular trajectory. The smooth change of the precession angle of the spinning axis, that is the precession, can be accompanied by nutation, that is a regular nodding of the nutation angle. It is important to mention that asymmetric tops will typically show chaotic behavior. Presence of dissipation can lead to exotic dynamics like the inversion of the TP top. We only investigate the pure precession, that is steady nutation angle of symmetric tops exposed to a torque or heavy tops where dissipation can be neglected. So I will show visually what is rotation here and what is precession and what is nutation. See, rotation is spinning around its own axis, but while spinning around its own axis, the same body also with its axis of rotation, it is making a circular. See, if you observe this point, if you draw, I will show you. If you follow this, so if you follow this, so this point is making a circular path. So while it is moving, it is making a circular path. This body is called rotation or spinning, and here it is precessing. That means it is moving along with its axis of rotation in a circular path. And nutation, if you have observed, see the wobbling here, how the body is wobbling in order to rotate or in order to precess. This is called as nutation. So this is rotation, precession, and this is nutation. So by taking the symmetric top example, we can also explain the movement of the earth. So if you observe, this is the equator, and in the down bottom we have south pole, and in the upwards we have north pole. So let us say this is the axis of rotation of the earth. So direction of the earth's spin is this, showing this. So in the same way as the top rotates as well as precesses, the same way the earth rotates around itself and also precesses around the sun. So that if you observe here, see, while earth is rotating around itself, around its own axis, so it also precesses in a circular manner. So its axis of rotation also moves in a circular path. So Earth's axis now is in this position, let us say. So this is the Earth's orbit, so Earth is revolving around its own orbit and also revolving around the Sun. That means it also precessing around about its axis, that is with a 23.5 degrees. If you see here, so one more visual. So top, so what happens when it is spinning? This is called spinning. If you might have observed, small circle. This small circle is representation for spinning of the top. That is, the top is spinning around this axis. So when the top is spinning around this its own axis, it also starts rotating or revolving with its axis in a circular way, in a bigger circular way. So that is called as precession. So if you observe, the Earth is also like a spinning top only. So if you observe here, there is we have seen here 23.5 degrees somewhat daily rotation, that is daily rotation 24 hours. So this is called as spinning. And if you observe this to precess with its axis, so the Earth takes nearly 25,700 years. See, this animation is more clear. See here, the Earth is rotating around itself, as well as it is precessing like a spinning top, making a circular path along with its axis of rotation. So if you observe here, so this is how we can show visually to the students how the Earth can behave like a spinning top. So few points I want to highlight, that the rate of precession, if you observe, is inversely proportional to the angular momentum of the spinning top. But then the rate of precession is independent of angle, and also it is also independent of mass, but depends on mass distribution. Now precessional velocity vector is always associated with its top. So, and few more points regarding precession is that so in this way we can show the precession of a top visually, so that you will understand in a better way. So thank you for your patience listening. Signing off for today's session.